It's September 11th, 2015. I'm Chris Babel, and I'm here with Sanjay Sarma. Sanjay is the Fred Fort Flowers and Daniel Fort Flowers Professor of Mechanical Engineering at MIT, and MIT's first Dean of Digital Learning. Before that, he was director of MIT's collaboration with Singapore, which led to the establishment of the Singapore University of Technology and Design, or SUTD. Sanjay also co-founded the Auto ID Center at MIT and developed many of the key technologies behind RFID systems that are now in use worldwide. He was also the founder and CTO of OAT Systems. Sanjay received his bachelor's degree from IIT, his master's from Carnegie Mellon, and his PhD from Berkeley. He's the author of academic papers beyond count and the recipient of numerous awards for teaching and research. So Sanjay, thank you so much for coming in today. We're looking forward to a fascinating story. And I want to just begin kind of, in a sense, at the beginning. When you were growing up, was engineering, technology, science, something that immediately came naturally to you? Was it something you always knew you would pursue, or was there an epiphany?
No, the story doesn't involve any sort of romantic epiphany. My great-grandfather was an engineer. My father was a nuclear physicist. Cousins and uncles were engineers, and I was always very 3D. I like 3D things. I like to make things. I like to shape things. I remember when I was 6 years old, my father and I booby-trapped something that I think may have bothered my mother at some point, using a clock. So no, it was it's a lifelong interest in making things.
Mm-hmm. Where did you grow up, and what kind of you talk about sort of a lineage of scientists and engineers. Tell me a bit about your home environment.
Sure, yeah. I grew up, I had a wonderful childhood. I was the only child of two very intellectual parents. We moved a lot. My father was an honest bureaucrat, which meant he kept getting moved around India as he fought with politicians, or he stood his ground against politicians. So I lived all over India. I mean, we moved maybe 10 or 15 times when I was a kid. And I had to make new friends, but I always found the kids I wanted to hang out with. Childhood was lovely. We very sort of science-oriented, history-oriented, intellectual, a lot of reading. My grandfather and grandmothers, both sides, lived in the South. I'd go hang out there, and there I'd meet cousins who had very similar interests. And one of my grandparents, one of my summer vacations would always be near the sea. There's a big shipbuilding industry, and we'd build little model ships, and we'd fight battles between ships. India has a festival called Diwali, which is about firecrackers, and we'd use those to build cannons, and the ships would shoot at each other, and it was a very joyful sort of upbringing, and with a lot of friends and family and so
on. Where did you attend high school? Were you moving during that time, or did you at some point sort of settle into an area as a teenager?
Yeah, we finally, when we settled, it was in New Delhi. I went to Delhi Public School, which, despite its name, is a private school, and had a really terrific set of friends there who were all a little bit sort of nerdily, a little bit wild, but a little bit in a nerdy side. There was no edge to it. It was sort of fun-loving, So I grew up in Delhi. Love Delhi. But I know India very well because I lived in different parts of India.
And when you were, say, 13, 14, 15, and really thinking about your life, I mean, what did you imagine that you would be? I mean, was it professor of mechanical engineering, or I know you were interested in technology. Were there other sorts of dreams that were part of the mix then?
It's sort of interesting. I had a couple of cousins go to IIT. Getting into IIT is not easy, and so I remember when my mother and her sister sat me and my cousin down and said, boys, when you grow up, it's a poor country, and there weren't that many opportunities. This was when India was still somewhat socialist, and boys, you need to make an attempt to get into IIT because there aren't that many options. And so we studied fairly hard. I was probably not as studious as a lot of kids, but we worked pretty hard. But we also had a lot of fun, and I spent a lot of my time either taking these coaching classes or cycling somewhere, and or playing badminton or playing tennis with a group of friends. The Indian system at that time was still pretty free. I think what's happened since, I worry, is that things have become more tight in the sense that a little bit more competitive, and I worry that maybe things aren't as you don't get as much freedom to sort of mess around and have fun anymore.
Tell me a bit about IIT itself. I mean, what was your plan of study when you went there, if you had a plan,
Right.
or if it was were you still sort of doing?
Right.
being
You
a
asked me,
freeform?
did I want to be a professor? I didn't completely answer that
that's-
question.
Yes,
I should say that honestly, I had no idea. I just wanted to become an engineer, and at various points, I wanted to do different things. I was sort of interested in cars and vehicles and robotics. I was very interested in robotics, but how I was going to practice that, I wasn't sure. Growing up in India, the epicenter is very different, right? I mean, Japan is close by. India was very friendly with Russia at that time, Soviet Union. So I wasn't sure where I wanted to end up. I did meet a couple of people from MIT, and I thought, hi, MIT is pretty cool. I met someone from Bell Labs, and I was very impressed with Bell Labs. But I don't think I had any specific ambition per se.
So, arriving at IIT with sort of a general idea of what you wanted to do, but not necessarily a specific plan. I mean, tell me about the environment. I mean, obviously, it's a extraordinarily prestigious school, a difficult school to get into, as you mentioned, and one that certainly made its mark on the world. I mean, what was the environment there at the time you were a student?
Yeah, I have somewhat mixed feelings about MIT. First of all, I was a kid. Frankly, some would call me still a kid. I wasn't. First of all, let me just talk about myself. I was fun-loving. I wasn't very mature. I didn't know what I was doing really. Maybe perhaps I should have gone to IIT a year later. In India at that time, everyone wanted to go early, so for some reason.
How old were you?
I was 17, maybe I should have waited until I was 18. I just turned 17 when I went to IIT, so I was basically 16. And that's one part of it. IIT, I was surrounded by just exceptional intellect. I mean, these really, really, really smart young people. Exceptional. Obviously it's the only undergrad school I've been to, but I don't think seen the same level of intellectual intensity. Having said that, a lot of the kids were like me. They were a little bit immature, So that was sort of one piece of it. I had a great time in IIT. I was sort of the wild kid there. I wasn't the most studious one. But I had a lot of fun. I did a lot of projects. I was into projects. I had great friends who remain to this day dear friends, who have done well in life, and who, when I see them and when they see me, it's like back in the 80s. We're very close. Pedagogy was sort of interesting. I really liked some professors. They were really great. I mean, they inspired me. But a lot of the pedagogy didn't work for me. And then you could couple it with the fact that, as I said, I was immature and I remain to this day. It just didn't work. I couldn't sit in classes and take notes and then sort of stay quiet and then, regurgitate them in an exam. That didn't work for me. But the project classes were great. So I walked away from IIT sort of questioning myself, actually. What did I learn? And what's the best way to learn? And the best thing that happened to me after IIT was I went to work on an oil rig in Scotland. Actually, I didn't go immediately. I made an attempt at going back to grad school, and I said, no. And also I had some personal issues I had to deal with, and then I went to Schlumberger, and that was the best thing that happened to me. It's because it was when I went to Schlumberger that I realized that all that stuff I'd learned could be applied, and I found myself questioning why I hadn't been told that, or why I hadn't sorted out myself. And the moment I started seeing the application, the world opened up. Now I knew why controls was important, or why mechanics was important, and why a failed pipe on an oil rig which can be so deadly, could have been prevented by modeling the strength of steel, or why a pressure vessel, which we learn the analysis for, was suddenly relevant. So for me, I sort of take my time in the North Sea as a part of my education. It was as much education for me as IIT, because it did many things. It was sort of a boot camp. It sort of straightened me out. It was a maturation. I matured. And most importantly, it put everything I'd done in perspective.
So how long were you working at Schlumberger? Was it brief or?
It was brief. I'd hurt my knee before I went to Schlumberger. I had an accident at IIT playing soccer, actually. So while I was at Schlumberger, I had a great time. I was there for. I joined towards the end of towards the end of 1989. I left in mid 1990 because my knee was unstable. Eventually, I had to have surgery and get screws, and my ACL gave up on me. But I was there for through the winter of 1989, and I left, I think, in August 1990 to go to grad school.
Winter in the North Sea?
I spent the winter in the North Sea.
Well, I see that you're doing a wonderful job of laying the seeds for things we'll talk about later when it comes to pedagogy and
what did Steve Jobs
education.
say? You can connect the dots backwards.
Yes, exactly. So that's so congratulations and thank you for making my job so easy. But let's talk about grad school and the decision to, first of all, to go to grad school. Whether that was sort of the moment you said, I think an academic career is the career for me, and also pursuing graduate studies in the United States, what your familiarity with the U.S. was, and just what that decision entailed for you.
Yeah, I went to grad school partly because of my worries about my knee. Being on an oil rig with a shaky knee is not a good idea, and I didn't realize eventually I had to have a major surgery and so on. But I had friends in grad school, and they were telling me stuff. I remember talking to one of them, a very dear friend of mine, actually, who got me to go to CMU in 1990. And he was telling me how much fun he was having and so on. And I had already applied to Carnegie Mellon and a bunch of other schools. I got into CMU. And so he went and talked a professor there into giving me a research associateship, a research assistantship. And I moved there. CMU really appealed to me, actually, because of robotics. I knew America quite well for a variety of reasons, not the least of which is my father got a degree at Harvard. So I sort of knew, and I was a young man when they came here. I wasn't a child. So I had a pretty sort of interesting insight into what American education was. Coming to America was seamless for me. It's sort of interesting. Growing up in Delhi, you would think it would have been a culture shock, but Delhi was in some ways closer to Pittsburgh than a village in India. Growing up in Delhi, it's very strange. Plus, I had all these IIT friends, but I also had a lot of American friends that I made immediately. People I've stayed in touch with over the decades. So it was a very smooth transition. I had some money from Schlumberger, so I was the guy with the car, so everyone wanted to hang out with me. I think I taught a dozen people how to drive in Pittsburgh. So I loved America instantly. Really enjoyed it.
And did you come with a definitive research or academic plan in mind? I mean, you mentioned interest in robotics continuing, or was that still a bit of a work in progress?
It was a bit of a work in progress. I would be lying if I ever said to you I had a grand plan. I came because I was interested in robotics. I was interested in design, and the professor who wanted me to work in his group, he was in design, a wonderful man. So I went to CMU, and I worked in a combination of things. And the most profound thing that happened to me was I actually enjoyed learning. I enjoyed it. After going to IIT, after all the troubles of getting into IIT, in IIT, just me, as I said, I hadn't grown up. But perhaps the circumstances as well, the way education worked. For some reason, after my work experience, which put everything in perspective, when I went to CMU, bam, everything clicked. I enjoyed every class. I aced every homework. I was so diligent, and there was a completely different person than 18 months previously. and I took a deep interest in a number of topics beyond robotics and design. It was fascinating, and I couldn't explain it. I can only explain it now, I think. But at that time, I didn't know what had happened.
So what do you think had happened? Was it you, or was it the way you were being taught, or both?
It was both. I really think it was both. And even me, I think different. When you're 17, you're still, frankly, you're a teenager, right? And some teenagers are mature, and some are not. And so we need to understand both things. People who come in, young people who come in, the teenage mind is so fertile and so it's so flexible. But also there's so many things happening in there, right? I mean, it's learning so many things, and we have to understand how to take advantage of that extraordinary opportunity for a growing person to guide them. I was immature, but the system was also sort of brittle. Now, when I went to CMU, I was older, so I'd settled down. But the way learning occurred, which was to focus on less but to learn more, that is at 180 degrees, frankly, to how education works to some extent in India, where the focus is on quantities and not on depth. Many, many years later, only a few years ago, when my little kid, my child, was in American elementary school, it's sort of interesting. When I was in India and all over Asia and Europe, it's fashionable to sort of make fun of the American education system. And unfortunately, Americans are falling into that trap right now, right? But actually, when my child went to school in America, I noticed a pretty fundamental difference, which was the focus in analytical thinking and analysis over facts and content. Facts and content are convenient because you can measure them easily. But analytical thinking is harder to measure, but actually helps you more in life, strangely enough, especially in this day and age with Google and so on, right? I'm not saying we shouldn't do facts, we should, but right? But there's something very profoundly practical and at the same time deep about the way education works in America, which I had only begun to scratch the surface of when I went to CMU.
Was there a point, maybe at CMU or maybe afterwards, where you started to think about teaching itself or education itself as a vocation or a calling that was appealing?
Well, you're accusing me of having a grand plan. I never did. No, I'm just kidding.
There must have been a certain point where you said, I can do this.
No, I never thought I'd enjoy teaching. I didn't think. I wanted to go do stuff, make stuff. And that's a good question. It wasn't until I started teaching, quite literally, that I realized that I actually enjoyed it. I'm obviously not very introspective. I enjoyed the research a lot, though. I really did. I enjoyed the people, my lab mates and the larger academic setting. And I enjoyed the fact that in a college, you can hear people on the one hand discuss Shakespeare and on the other hand discuss engineering or disagree on politics or talk about international relations. I really enjoyed that, but I didn't see that as where I would end up. I didn't see that as where I didn't not see it as where I'd end up. It just never occurred to me. But I did think I would go work at a company and build things.
So you eventually went on to Berkeley. Were you teaching while you were in grad school, or was that when you started to have these classroom experiences, or?
So I ended up at Berkeley, strangely enough. Actually, my choices were MIT. I got into both MIT and Berkeley. I ended up at Berkeley because my wife, who I'd met at IIT, was a grad student at Berkeley. So I moved to Berkeley. I did some TAing there, teaching assistantship. And I wasn't very good. Or at least I didn't enjoy it. And there was a lesson in there for me as well, which was because when you're a TA, the class is designed, right, for the curriculum, and everything's sort of laid out, and you're just grading assignments. But I also realized that probably, in retrospect, I think one of the reasons I didn't super enjoy it was because I didn't have the opportunity to redo the curriculum in a way that I thought was practical. Maybe I'm a control freak. It wasn't. I don't think it's that. But I was just a sort of a spoke in a wheel, right? A cog in a gear. Um, I mean, it was okay. I wasn't great at it, but I enjoyed the research a lot. But I did enjoy, I have to say, not the actual grading. I did enjoy uh, the one-on-one interactions with students for a selfish reason that it forced me to reorganize my own thinking. It just, I see teaching partly as it's sort of like inviting someone to your home. You got to clean up your home, and so I found that strangely sort of clarifying. So, but that was entirely selfish. I don't know if the students enjoyed my teaching. I've met a few of them since, by the way, and they've been generous in saying that they haven't sort of commented on it, certainly not negatively, but maybe they were just being generous.
So you mentioned research. As you progressed through grad school at CMU and then at Berkeley, I mean, what were the research topics or issues that you found yourself being really drawn to and that you started diving into?
Yeah, in CMU, I was interested in mechanical engineering design, and in particular, I was very interested in a field called it's optimization, and I was interested particularly in taking the information you know about things to make optimization more efficient. So it was sort of a semi-mathematical thing, but I was also partially involved in a number of other projects around in robotics and design and so on. When I went to CMU, I went to Berkeley. My research shifted. I was involved in building machine tools, CAD systems, in something that is called planning, which is applied both to robotics and to manufacturing. And so it was all about automation, so a form of robotics, if you will. But everything from spatial stuff to controls to software. It was a very sort of integrative approach.
So tell me about coming to MIT.
So when I graduated with my PhD, my PhD advisor said, "Have you applied?" And I said, "No." He said, "To anything." I'd applied for like a couple of jobs. I was a little blasé about it, frankly. He said, "You should go look at MIT." And my PhD advisor is a wonderful man, Paul Wright, who remains a friend and a mentor to this day. So I said, "Paul, do you really think I'll be, this is good for me?" He says, "No, you must do it. You should go look at it." So I interviewed at MIT, and I actually got rejected. And so, but then someone said, "Come back and interview for this other position." Actually, Professor Alexander Slocum, another dear friend. And I came back and interviewed. And I went back to Boston, and my wife managed to wangle a ticket to Alaska. It just happened to be in November, by the way. So November, we were in Alaska, hitchhiking and hiking. And one day, I remember calling my answering machine back in Berkeley from a telephone booth in Denali National Park. We could actually literally hear the wolves in the background. And there was a message in the answering machine saying, "You need to call, please call MIT, from them." And I called them, and they went, "Well, we have an offer for you." So in December of 2000 and, which year was that? December of 1995, I moved to MIT. And there was a massive snowstorm, I remember. And I walked into MIT over the Harvard Bridge, 2 feet of snow in a suit. And MIT is closed that day. So that was my...
But MIT never closes.
And MIT never closes, exactly. It's actually we close a lot more now, but at that time it never closed. And so I came to MIT, and I started working with a couple of people who remain dear friends, Alex Slocum, Dave Trumper, at the Lab for Manufacturing Productivity, where I continue to sit. And my research, I had a very clean idea of what I wanted to do. Rapid prototyping, had just started to take off at that time. Ellie Sachs, one of the pioneers of that field. But rapid prototyping is an additive process where they take particles and add up to build things. There is a more traditional process, which is very, very powerful, called machining, milling machines, etc. And my dream was to create rapid prototyping using machining. there's a lot of manual intervention that goes in. And my dream was to be able to take a CAD file. At that time, we still had floppies, put the floppy in, and then have a finished part come out, not by 3D printing, but by machining a hunk of metal. And so I threw myself into it. And I've always had a very sort of, I've always prided myself in being able to bridge across fields. I did computer design, I built machine tools, and my group and I, we invented new manufacturing processes. We worked on polymers, we worked in metals, we worked in a whole bunch of things. And so that was my research for the first few years.
So at some point you became interested in RFID technology and all of the promise of that, which ultimately, not to get ahead of the story, led to this concept of the Internet of Things and,
Right.
and so many other things that all of us do now. What was the genesis of that? How did you become involved in RFID, and what did you see as the promise, and then maybe compare that to where things have gone?
Yeah, it's a good question. So in the late 90s, what was happening was we were making improvements in manufacturing by 3%, 5%, which is huge, by the way. But a company could get a 50% improvement by moving to Southeast Asia in economic performance. So these battles that we were fighting were on a front that companies didn't really care about. So we were doing that. I continued to do research in manufacturing all the way until 2004 or 5. We kept doing some, I think, good work. But in 1998, a colleague of mine, an MIT man by the name of Dave Brock, actually, he's the guy who pulled me into RFID. I knew about RFID, and we thought about it. But he said, Sanjay, we should look at it. And, he had this wonderful idea that why do robots try and recognize an object? Why can't the robot just ask the object what it is, right? So if you imagine a robot assistant at home, we were dreaming of it then, and you have a cup, right? Maybe the cup has an RFID tag, and the robot says, hey, how do I pick you up? And the cup says, well, you hold me by my handle, and my friction is coefficient is this much. And you come in with this approach path. That was his idea. It was beautiful. And so I started looking at RFID with him. And then we got a couple more people involved. One person, Sunny Su, is another professor of mechanical engineering. He's left since, but he lives in Shanghai. We were very close, still sort of remain in touch. And we also had a wonderful colleague from Procter & Gamble, Kevin Ashton, come to MIT because he understood. He was a brand manager at Procter & Gamble. He understood how to place brands in retail, and he brought the whole retail perspective. And Kevin became the executive director of the center in charge of, and he was great at both helping us frame the vision of where this could go in internet and commerce. In retail and commerce, but also together we were very good at, frankly, persuading companies like Walmart and Procter & Gamble and Gillette and standards bodies like the Uniform Code Council. These are the guys who do barcodes, a great organization, to become sponsors. So that's how we got started. But the real idea, at that time, we didn't call it the Auto ID Center. We called it the Distributed Intelligence Systems Center. The idea that RFID tags could be fiducials on inanimate objects. And these inanimate objects could suddenly become accessible over the internet. It's like a database, but a physical database, right? You could see what was in a room even without seeing it. And it was Kevin actually came up with the term Internet of Things because we were trying to explain this to people, and people didn't even believe. Very few even knew what the internet was. And if we said you could put the internet, the internet would be accessible in a room or a telephone, people would laugh at us. So we decided to turn that into something of turn it into a shtick. And we started, Kevin suggested calling it the Internet of Things. That's how that term started. The reason that we got into RFID actually is that we started talking about this, but there was actually an RFID industry already that saw us as a bit of a threat. I'm not sure why. But as I started looking at RFID personally, I began to realize that the tags were far more expensive than they needed to be. And the protocols were they were old-fashioned. I wasn't a communications guy, but I knew enough. So I started studying it. The protocols were old-fashioned. The manufacturing processes were old-fashioned. And they weren't using the internet. They were putting a lot of data on the tag, but you could have put it on the internet. So, uh, so I said, why don't we make them cheap? And Kevin Ashton, the reason we met and got excited about it was he said, well, if you make them cheap, the retail industry will definitely adopt them, right? And I started thinking about how to make them cheap and how to build a system. And I'm an engineer, so I started piecing things together. So that's how I got into it. But then we actually tapped a real um, vein of need, necessity. Necessity is the mother of invention. And that was the fact that to this day, the supply chain that feeds retail has a lot of uncertainty and a lot of errors in it. And at that time, companies started taking it seriously. And so we tapped right into that. And that's how it got going. And that's how it got sucked into the vortex. And it was a wonderful vortex.
So I think the Internet of Things, it's interesting to hear that its origin is actually some time ago, because it's a term that is only now, I feel, becoming current in sort of, popular culture. I mean, there was a radio ad I heard the other day making sort of a joke about someone's toaster being online. And I was wondering if you could just think about that sort of revolution, which, I mean, clearly is happening in fits and starts, but of everyone's stuff being online, not just supply chain, but
Right.
everyone's stuff.
So right in the beginning, actually, Dave Brock and I, we were thinking of putting things like on the internet. You're talking about a toaster. I had a wonderful student, Joe Foley, who now teaches at the in Reykjavik in Iceland. Joe managed to purloin his grandmother's old microwave oven, and we put a microwave on the internet in 2000, and that was our defining vision of where this whole system would go. So here's what we built. We took a packet of food, we put an RFID tag on it, and what we would do is when you put the food inside the oven, microwave oven, it would read the RFID tag, go to the internet, download a recipe for microwaving, cook the food, and the food came out. So that's when it started. When you start something like that, usually takes some time for pieces to fall into place. America, one of the great things, I'm a huge fan of science fiction. And I think science fiction has done tremendous things for American creativity. 3D printing, right? In some ways, the vision of that was in Star Wars and Star Trek, right? So one of the things is that when you anticipate these things, you lay a framework. But not all the pieces are there. The internet was slow. It was expensive. Wireless wasn't really there. Wi-Fi hadn't taken off when we did this, right? But once the framework is established, either by sci-fi or something like our project, I think what happens is it settles in the collective consciousness of the technorati. So I think it sort of settled there. And as other pieces fell into place, this sort of unconscious became conscious. And that's what we're seeing now. And we, as in Dave Brock and Kevin Ashton and Sunny Sue and I, we stood on the shoulders of others who thought of other things that may not have been the same thing, but created a framework that helped us think this way. So there's a sort of a silent meme, a sort of a mental framework that sometimes we don't acknowledge or surface, but a lot of engineers share. It's sort of like what literature does for us as well, in my view. Literature gives us these narratives, that take shape over time. And then we fill in, they'll help us build new narratives. So similarly, I think there's a sort of a technological narrative that we help frame, and we used other frameworks to build it. And that, over time, is now becoming actualized as we speak.
So I want to ask you about another narrative that I think has shaped your interests, entrepreneurship and innovation, and clearly building on some of the sort of research innovations that you've been part of. would be one part of that story. But what about just the idea in general of being an entrepreneur, being an innovator, being disruptive? I mean, is that something that you felt was always part of you, or was it again something that you fell into as a narrative that appealed to you?
No. So I was always a sort of a cocky smartass, but I'm not sure that I was maybe innovative. Maybe I was always trying to invent things. But entrepreneurship, I actually consider myself more an admirer of entrepreneurs, someone who wants to be an entrepreneur. It was wonderful in America again to see people just take that risk, just quit their job, take a loan and start a business and be willing to fail. That not being afraid of failure, being able to live on the edge. There's something in India you couldn't really do because failure was actually much more stark there. You starved or something. It was much more. There weren't that many safety nets. But even then, taking a risk is something that takes gumption. So I have a great deal of respect for entrepreneurs, and I think that we should. It's become fashionable now, but 15, 20 years ago, I mean, I don't think we really gave them the respect they deserved. So in the 90s, because of that respect, because of that awe for their risk-taking ability, it was more me trying to sort of see if I could do it, right? If I could muster that strength. In some ways, I've always been at MIT, so I don't consider myself much of a hero. The people who actually quit their jobs, those are the heroes. So I don't think I didn't ever do that. I took some risks, but not that serious. But there is something addictive about trying out new ideas. I've always felt that it's important to have opinions, They don't have to be crazy. They don't have to be sort of black and white. And you should be willing to give them up if you're wrong. But I've always felt that A, it's good to have opinions, and B, it's good to question. Why accept everything for what it is? Why not question? One example I use is for years, we all have these backpacks, but we always use one strap, right? Until the kid who invented the one strap bag, right, with only one strap for your back. That was innovative, right? So this questioning, the ability to take risks and try and make a business out of it, those are things I've always I've really respected. So I've tried to bring that into my life, both in our research group, but also in trying to start entrepreneurial activities. And I have never regretted it. In fact, it's informed the way I do everything pretty much. The other thing I'll say about entrepreneurship is the ivory tower that we live in is beautiful and it's wonderful. It's also a cocoon and it's a microcosm. So for me as a professor to go out there and try and make a sale and to fail and to walk out of a sale with my ego in tatters, not fun at that moment, but an extraordinary learning experience. Learning about the real world it's I think everyone ought to do it, everyone should try it if they get a chance. So I think that entrepreneurship is and innovation are going to become more and more important for society, period. But also it's been great for me.
So I want to ask you about another narrative that I think has shaped your interests, entrepreneurship and innovation, and clearly building on some of the sort of research innovations that you've been part of would be one part of that story. But what about just the idea in general of being an entrepreneur, being an innovator, being disruptive? I mean, is that something that you felt was always part of you, or was again something that you fell into?
That's a great question. So the first class I taught was in a topic I hadn't studied in a long time. And that was actually the best thing that happened to me. And so I had to relearn it, right? But of course, I'd studied it a long time ago, so it came back much more easily. But I had to question the sequence. How do you explain that? Why is that useful? So I had to rebuild a narrative. The pieces were there, but the connective tissue was missing. And I was also very fortunate in that some senior colleagues I was teaching with, I was able to watch them. And But the most important thing was rebuilding that narrative. And I began to realize that in many cases the narrative is broken. We just teach stuff in a certain sequence, not thinking about how the student is going to construct the understanding in their mind. So at a very early in my teaching career, I began to realize that we teach in a way that's convenient for us. We don't teach in a way that a student can accept and assemble a model of the world. Right? It's sort of like if I gave you a bag of proteins, a bag of sugar, and a bag of carbohydrates and said, eat it, trust me, it's a Mars bar, right? That's sort of how we teach, because it's convenient to do all the proteins in one shot and all the carbohydrates in one shot, because you can have a protein week and a carb week, and that's sort of how we teach, right? So I began to, because I was learning myself, I was sort of relearning it. Only much later did I realize that there's actually a scientific basis for this. I began to sort of reverse my teaching, and I was forced to do it by circumstance, and reassemble the teaching, the components, in a way that was friendly to the student's mental model. I was also able to anticipate. I also learned the importance of anticipating ways in which the students might misunderstand stuff. And in some cases, letting that happen and then correcting it. In some cases, heading it off at the pass when I thought it would be distracting. So that was actually a wonderful thing, that first class that I taught. That's one. The second thing I realized is when one constructs an exam, a lecture or an exam, every one of those things is an opportunity to really shape that mental model. And finally, I just found that our students, and this is MIT, I'm not sure I would have enjoyed this as much in another school, our students are just wonderful. They're creative, they're thoughtful, they're very decent, they have a great sense of humor. So the principle I came up with was what I call inspire, instill, and anchor. So the idea is you inspire. Why do you need this? Why is this going to be relevant? And so you create room for the student to sort of absorb it. If you just throw it at them, they don't know what to do with it. It's just going to bounce off. But you have to inspire it. Then you instill or install, depending on the word convenient, which is more a convenient explanation. You want to, at that point, once their guard is down, they're willing to open it, you give them a small morsel of the information that they need. And now they know, it's sort of like they're building a tree of information. They know where that information goes, right? And then you anchor it, which is once they have it, you anchor it with something. So, for example, by the way, in a consulting gig I did, this showed up in the following way, and that makes it vivid, right? And the final thing is our students are actually great fun. So there's absolutely nothing wrong in having fun with them. They have a sense of humor. They play ball. If you make a mistake, they're actually forgiving. If you confess that, hey, I made a mistake, let me go fix it. And what that did was it made it so much fun. And so I sort of got into it. And that's really the initiation into learning. Until the day I did it, I had no idea I'd actually find it fun. But somehow I figured it out and it worked out for me.
I'm just curious, what was the course that you first taught? And thinking forward, what were some of the courses that you developed or that you were able to sort of take this process or this approach and apply to that you were really proud of or you feel like you made a difference in?
So that course was a course that doesn't exist, or it's been reformatted. It was called 202. It was essentially applied mechanics, solid mechanics, material science. It now sort of exists in the form of 2002. But over the years, I've actually taught maybe more courses than most faculty at MIT. I've taught mechanics, I've taught dynamics, I've taught design, I've taught manufacturing, I've taught advanced topics in math, I taught a course on finite elements, I've taught a course in RFID, I've done a lot of professional education, so I've sort of been all over the place. But in all of them, what I've ended up doing is taking the curriculum and deconstructing it and reconstructing it in a way that I felt would be more friendly to a student's construction of a mental model. And initially it was sort of unwitting, but over time I've sort of firmed up my understanding of how I teach it is inspire, instill, and anchor, and then keep it loose, have fun. And each course, when you actually look at the subject matter, the way you do that varies. So, for example, if you're teaching manufacturing, the way you do that is very different than if you're teaching mechanics. Very recently, in the last few years, through my discussions with a number of colleagues, I've begun to understand there is actually cognitive science that explains that this may actually not be this is not a bad idea. This is the way to do it. There's actually a whole field of education or a philosophy called task-centered instruction, and I think that pretty much sort of summarizes what I did, but without being told that was what I was doing.
So at some point in your career at MIT, you started thinking about these issues and being involved in these issues, not just at the course level, but at a broader level, sort of setting institutional goals or even goals or sort of concepts beyond MIT. And I was wondering if you could maybe talk about that evolution for you, just as far as your career goes, and how your thinking was shaped as you did that.
My life at MIT has been sort of interesting. I did my teaching. I'd actually get really good teaching ratings, and I was very fortunate to receive a couple of awards and so on. And I continued to do my research. And research kept me very busy. I left MIT for a couple of years to a startup company, et cetera, et cetera. But because I had these good teaching reviews, I would be asked to do new courses, which was very stressful because, redoing a course, that's very difficult. But in the process, it also forced me to sort of hone my skill. And I began to form opinions. That's the dangerous thing, right? To have opinions about how to do it right and how not to do it. Opinions that thankfully later on I found out do line up with what we know from science. So in 2010, the then provost, now president, asked me to take over and run the establishment of a new university in Singapore University of Technology and Design. And many of these instincts that I had turned out they lined up with many of the instincts of the faculty who had self-selected to participate in this project. I was the director. And I had an amazing 2.5 years establishing, working with Tom Magnanti, who's the president of SUTD, my former dean and a wonderful man, shaping the pedagogy of a new institution. And the amazing thing was, because it was a new institution, we could throw out all the rules and we could reconstruct what we thought was right without any legacy, etc., no change management. And we were able to apply a lot of these things. SUTD, a couple of weeks, graduated its first cohort, and the students are different. It's amazing. So I did that for 2.5 years, and that was extremely rewarding. Actually almost 3 years. And I also, as I said, my sense of learning science, if you will, sort of firmed up instinctively, right? I mean, I had a much better science and sense of what worked and what didn't, and what students really wanted, and student psyche, and what they lacked, and some of the problems, frankly, in our system at MIT. So in 2012, the new president asked me, Raphael, the same gentleman, asked me to become the director of digital learning at MIT. And I saw it as a golden opportunity, not just, of course, to impact the world with MITx and edX, which was an extraordinary thing. As someone who grew up in India, so far away from all this, I think it would have been so amazing if I had MITx. But also, frankly, to use some of those tools to rethink how learning happened on campus. Meanwhile, edX was going great guns. Anant Agarwal is an amazing guy. And so I was also offered the opportunity to sit on the board of edX. So these 2 or 3 things began to come together. And so when Ike Chuang and I started setting up MITx and the Office of Digital Learning at MIT, also leveraging the great wealth of resources in also OpenCourseWare, also working with OpenCourseWare to do, to extend that mission. We brought Vijay Kumar's group in. At that time, it was called what was it called?
OEIT.
OEIT. Yeah. So long ago.
Yeah.
I'm just kidding. So we brought OEIT in. Now it's SEI, and we created a new engineering group. Then we brought AMPS in, DE in. All these amazing groups of people gave us the tools to actually implement what we independently, but also we agree, felt was the right thing to do at MIT. So it's an amazing opportunity here to rethink education. I actually think that the way we educate, less so at MIT than the rest of the world. There are large parts of the world, I think it's frankly outmoded, needs to change, and we are the tip of the spear.
So all of this was going on sort of at a very interesting moment in terms of education and public perception about education. I mean, I tend to think of with this sort of the MOOC explosion. We talked about the Internet of Things suddenly hitting the public sort of consciousness. In some ways, in 2012, that's what happened with MOOCs. I mean, suddenly digital education became synonymous with MOOCs, but of course, I think it's also much more than that. I was wondering if you could talk about, first of all, the MOOC explosion and your sort of your take on that, but also clearly ODL is more than that. How that fits in.
So when MOOCs were announced, there's a lot of, I think, clearly education is such an important thing. By the way, one of the things that really impacted my interest in education was the fact that I had a kid, right? And I watched her, like, as you do, watched her learn and watched what she enjoyed. In America, there's something of a crisis in education. Costs are high. Online education hasn't always been good in America, or hasn't been successful necessarily. So there's a lot of pent-up interest in this. And when MOOCs landed on the scene, there was a lot of justified and justifiable interest in it. But also it unleashed some pent-up good and bad feelings, right? So that caused this sort of the up and down cycle, right, about MOOCs. It's sort of a emotional roller coaster. But, students are voting with their feet. And I would say that in every year that I've been involved in this effort, the reality has been this way. Sentiment's sort of gone up and down, but it's just going up. In fact, if anything, it's hockey sticking. So the MOOC explosion, I wouldn't call it as much. I wouldn't call it an explosion as much as a front that has moved steadily and with increasing pace and with increasing inevitability. Right? Okay. I mean, there was a flurry of articles and there was a flurry of negative articles, but the first articles got it right. This is on its way. Okay. But having said that, the implications on campus may be even greater. Much has been said about, MOOCs will take out, universities. No, they won't. There's something magical that happens in universities. And professors who worry about MOOCs should find their mojo, frankly. They should stop worrying about it. Their impact on students is profound. The few professors at IIT who impacted me had a lifelong impact, right? MOOCs free your hands and to do more, free your brain to do more. It's sort of like saying, when books were invented, people thought universities would come to an end. No, they didn't, right? What happens between two human beings is much more profound. So that is what we're engaging in now. We're doing both research in learning and applying those learnings on campus. And there is no better indication of that, or no better proof of that, than the amazing uptake of online MOOC-related online technology on campus. As you know, 90% of us undergrads have already touched our online tools through campus and this has gone from 0 to 90% in the last 2.5 years. I don't think we'll get over 100% though. So we're nearly there. So I think that the MOOCs give you so many degrees of freedom in how you reformat education. You can take the stuff that you put it online, then create more time to actually talk to students, give them projects, work out issues they don't understand, build their mental model. I think it's an extraordinary opportunity.
So the excuse, if you will, for doing these this particular set of oral histories is the 100th anniversary of the construction of our current campus at MIT, the move to Cambridge. And so it's quite interesting to be talking to the Dean of Digital Learning in that context. Looking ahead at the future of MIT as a campus, as an institution, what do you think the impact ultimately is going to be? I mean, it's maybe for people who like the campus, it's a relief to hear you say it's not going away. What do you see as the blend?
Oh, I think we'll need more campus. If our EVP treasurer, I know he doesn't believe that, but if anyone thinks that somehow we're going to need less campus because we can go virtual, I would say no way. If anything, we'll need more. MOOCs make the real magic of MIT even more powerful. And MIT will continue to grow. Our campus will become more and more fascinating and fertile. This is the place where people will use an electron microscope one day and use a 3D printing another and do an economic analysis a third to concoct the next amazing thing. So in 100 years, I think we'll be celebrating the positive impact of all these technologies, digital included, in the extraordinary expansion of the impact of MIT on the world and on its impact on 20139, which is the space we occupy.
I want to ask a sort of an abstract question, and I'm not sure if I can articulate it properly, but one of the things that I've been very interested in observing when working with faculty on online educational
By the way, I said 2012139,
yes.
I meant 02139.
02139, yes.
I apologize.
Yes, not a date, but
not a date,
a zip code. The process of creating a MOOC, the process of creating online educational materials, forces or encourages people to think about what they're doing in the classroom in a way that's kind of similar to what you
yes.
did or described doing in that very first experience teaching a class. And that's been sort of for me at least, that was sort of an unexpected benefit or boon. And it kind of points to an interesting question about pedagogy and what online education might reveal about what works or doesn't work in quote unquote traditional or classroom settings. I was wondering if you have any thoughts on that.
No, it's absolutely, writing is the highest form of thinking. I think MOOCing is the highest form of pedagogy. I mean, what MOOCs do is putting stuff online forces you to really think through that narrative, the connective tissue. But if you're just going there and doing a live performance and you've done it 10 times before, you just go by habit, right? And you don't re-examine. So it's an extraordinary opportunity to rethink the way you present stuff. But it's not just that. It's also that it's impossible in a regular lecture to do a 10-minute lecture. But all the science tells you that 10-minute lectures are more effective, right? Not because you want to encourage people to sort of defocus after 10 minutes to check their email, but because after 10 minutes you can do a lecture-related activity that encourages long-term retention, right? You can do projects. You can anchor better. Everything I talked about, inspire, instill, anchor, all that stuff you can do better. So technology is not just a convenience that pushes content out of the classroom so you can do more project work. You can actually do many things more effectively for the brain when you use technologies in some ways. And the things that technology can't do, that only the human can do, you can actually open up more time for. It's an extraordinary opportunity for us to rethink, right? I can't think of any great analogies, but often change is the time when we improve things, right? And this is a time of change, and digital is a reason for change, and it's also a tool for change. But frankly, if 5 years from now, a year and a half from now, someone proves that digital actually is horrible, we shouldn't do it. I happen to think it's one tool in our quiver. It's an important tool, and net learning will improve.
You're, among other things, as the dean you're leading this really complex organization with a lot of moving pieces, a lot of divergent projects and goals and ideas percolating. I was wondering if you'd just talk a little bit about, this is really two questions, so we can take them in any order. One, how do you lead a herd of cats like that? And two, where would you like to lead that group? What do you see as the future impact of this new organization on MIT and beyond MIT?
Okay, so if I want all of us, to agree to one thing, it is that none of us has the answer. That's at some level, MIT exists because there is always a question to which we don't have an answer, and an answer that was right yesterday may be improved upon with a better answer tomorrow, right? So, in terms of leadership, how do we lead a group like this? My belief is that we need to inspire folks to, and I think they come inspired, right? It's such a great group constellation of characters. You open courseware, 180 million people, over the course of 15 years. That's an extraordinary achievement. What OEIT did, or the videos Amsys produced. These are all great groups. But the key thing is for them to understand the importance of this mission. Human beings are what we are because of learning. Right? If we couldn't learn, if we didn't have memories, if we couldn't plan, if we didn't improve, we'd be animals. Learning is, in fact, what makes us tick. Learning is what took us out of caves. Learning is what took us out of the hunter-gatherer stage and helped us design civilization and manage and improve. And this organization has the opportunity to pretty fundamentally impact that most important intellectual activity of humankind, right? Outside of feeding ourselves, learning is the next important thing. So the way I want to lead is to both convince people of that they can actually make that difference, but also empower them to make the difference. But also equally to be willing on a daily basis to give up ideas or be willing to modify ideas as new evidence accrues. Where would I like this organization to go? I would like for this organization to be the world leaders in this movement. I would like for our people to be the most coveted, the most successful, most importantly, the most committed people. Scientifically informed commitment, not dogmatic commitment to this extraordinary endeavor. And I think we can make that happen. All else follows. I believe that many of the individuals who are involved in this, and this sounds arrogant, but I truly believe this, so I'll say it, will write books about this someday. For example, how can digital tools impact high schools in India? Right? That's a project we're doing right now. How can digital tools be used to redesign the way we teach computer science, electrical engineering, robotics? That's happening now, right? These are all, and then how can digital tools be combined with in-class tools and hands-on tools? We're doing that right now. So these are all extraordinary steps, and this family is the family that's doing it. And I think once everyone's convinced of that, because the talent is there, things will just happen.
So we've talked about MOOCs, we've talked about some of these other sort of exciting initiatives that are percolating. Is there anything that's flying under the radar right now that you're particularly excited about? I'm not necessarily asking you to break news, but is there something that, just as in some ways online education was evolving and then suddenly it hit its moment of attention, in some ways, over attention, a year or two ago, but really it was, as you describe it, more of a front moving in. Is there a front that excites you that maybe people aren't really thinking about right now?
Yeah, I think there are two fronts. The first front is our understanding of the brain. In the last year, I've personally immersed myself in understanding what neuroscience and cognitive science and learning science and education science types have studied, and it's extraordinary. As we understand how the brain works, we will make advances in everything from, of course, medical conditions like Alzheimer's or dementia, but all the way to learning. How do infants learn? What's the best way to get infants to enjoy what they're learning and yet retain what they're learning? What should we not teach them because it's a waste of time, because they don't get it and we're just making things not fun? That is going to be one huge thing. And I believe that'll play not just a part in K-12 and higher education, which are sort of higher education is our sweet spot, K-12 is our feeder, but actually especially in professional education, because we are moving as a society from employees in large companies who are cogs in a machine to we're all going to have to become innovators. And technology is changing fast, and science is changing fast, and economies are changing fast. And so the professional, in my view, in 5 years, every professional will spend 2 hours a week just upgrading their skills. And we need to figure out how to do that efficiently, and the advances in our understanding of the brain will help all that. So that's one huge front that I see. Maybe it's breaking news. I don't think it is, but I don't know when this interview will go online, but I think by then this will become more and more apparent. The other one is credentialing. Today we have a credentialing system that is about more than 100 years old. You get a high school degree, diploma, 10 plus 2. Then you can get a 4-year degree or a 2-year degree, right, depending on which career path you take. Then you get a master's, which is 2 years or 1 year, depending. You get a PhD, if you want, right? But is the world ready for that? Is the world ready for something different? I think so. Let's say you get a bachelor's. Is that it? Or are you going to keep getting one more course every year, 2 hours a week or something like that? And if you do you get this different type of degree? We need to start defining these things, right? Maybe there are two types of bachelor's: a bachelor's, which is you're done, and a bachelor's, which is live, right? We got to think about these things. I see the struggles there and the questioning occurring right now, but I see that taking shape in the next few years. And I'd like MIT to play a key part in this, not because we're the only people who could do it, but because we have a lot of experience with online and so on, and so we should certainly be a part of the conversation. We should help guide it.
I want to be cognizant of your time. Is there something that you've been waiting for me to ask you, or a topic that you've been waiting for me to bring up that I haven't, and you're just dying to address it?
You know me too well, Chris. You've asked me pretty much every question that you could have asked me. You didn't ask me about my interest in cricket and tennis and sports, but we can do that some other day.
Anyway, well, I want to thank you for coming in. I really appreciate the time you've taken, and I think it's going to be a really interesting and an important part of the record of all of these changes.
Well, thank you. Thank you very much. Yeah. A great pleasure to be here.
Thanks.
Thanks, Barry.